All right, if we could have your attention here. I know you're used to seeing Chris up here, but unfortunately he has a commitment out of town, so I have to be here. I'm Tyler Dick. I'm a senior research engineer and associate director of education here at Railtech, and welcome you to the William W. Hay Railroad Engineering Seminar here at the University of Illinois. I know you've all been eagerly awaiting the return of the seminar series this fall, and I'm really excited to be kicking off with today's topic. It's a project that's very near and dear to my heart, which will become evident during the presentation. So before I introduce our speaker, a few housekeeping items. If you have a cell phone, please turn it off or onto vibrate or some other unannoying mode. If we have a fire alarm, so we're going to exit from the doors you came in, go straight out down to the stairwell, as long as that one's not blocked, down those stairs, out across Stoughton Street, and assemble by the Hydro Systems Lab. Use the buddy system, so look to your right and left to make sure those people make it out with you across over there. If we have severe weather, we'll continue downstairs. We'll go back into the old portion of Newmark Lab, down the stairs in there into the concrete bunker of the basement. Safest place in the county to be if there's severe weather. So we'll ask some of the students and faculty here that are familiar with that path to sort of lead the group down to a safe location. Not expecting any severe weather today, but just in case. If you didn't swipe your card in when you're getting the pizza, there should be a sign-in sheet. Do we have one going around? I think so. I think most people swiped in. If you didn't get a direct email announcement of this seminar, you can send an email or write your email legibly on the sign-in sheet, and we'll put you on our email list. For those of you who are joining us online, which today includes a whole bunch of great consulting competitors here at HDR, in addition to HDR employees. So our good friend Gio DiDomenico of HNTB is online, so shout out to Gio. Some people from different DOTs, UP, Nortrack, Hatchmont McDonald, let's see, a few other places here. Hanson, several other alumni at Hanson, Benesch Consulting, FRA, IDOT, Metra, Lochner, and LTK and TUV Rail Sciences, among others that are joining us online. So thank you very much for joining us online. If you would like CEUs for today's seminar, send an email to LB Fry with the instructions that were in the email announcement that went out to everybody. Also, last thing, ask the speaker, if we get questions from the audience, just repeat them, since they don't have microphones so the people online can hear them. Okay. So the W.W. Hay Railroad Engineering Seminar is sponsored by the National University Rail Center here at the University of Illinois at Urbana-Champaign. On behalf of everyone here, we thank the United States Department of Transportation for their ongoing support of the New Rail Center and events such as this one. It's appreciated by those here on campus and those participating online via the internet. So on to today's presentation. Fort Worth, Texas has long been a critical railway crossroads for both BNSF and UP freight operations and various passenger services. They all converge at a single railway junction known as Tower 55. By the mid-2000s, the outdated track arrangement at Tower 55 was no longer able to handle capacity for peak traffic demands of up to 120 train movements per day. So to relieve this congestion, BNSF and UP embarked on a $115 million project to add capacity at the Tower 55 interlocking. That was completed in 2014. Due to the difficulty of adding track capacity in a constrained urban area while continuing train operations, the complex project required 3 years of intense design and 17 months of construction. In recognition of meeting this challenge, the project also received the 2015 Dr. W.W. Hay Award for Excellence from ARIMA last month at the conference. Very exciting for those of us who are involved in the project. So we're very fortunate today to describe the design and construction challenges associated with this project. We have our speaker, Mr. Mark Martin from HDR Engineering. As Tower 55 project manager, resident engineer, Mark managed the HDR engineering team responsible for design and construction management of the second mainline track through downtown Fort Worth. Mark is a senior rail project manager at HDR Engineering in Fort Worth with more than 30 years of experience with various heavy rail transit and highway projects. He also worked in the office next to mine for 6 years, right? 6 years together. That's right, 2 different buildings, but offices still next door to each other. Mark is a longtime resident of Fort Worth, not Dallas, but Fort Worth. He's a very proud graduate of Texas Technological University, guns up, right, and a professional engineer in the state of Texas. So please welcome Please join me in welcoming our speaker today, Mr. Mark Martin, who will present the WW Railroad Engineering Seminar entitled Design Construction of BNSF UP Tower 55 Project, Fort Worth, Texas.
Good afternoon. Good to be here with y'all. On this presentation, I know everybody in here is an engineering major, but from my experience, not everything in life is geared black and white in engineering, so I've tried to portray through the design aspects as well as construction the different facets of being a project manager for a major project. So when you see some of these things, you're going to either say, that doesn't relate to me, or you're going to say, oh gosh, I got to pay attention in other worlds. Again, this project was located in downtown Fort Worth. The Union Pacific, most of their expense was in a new signal, block signal setup, replacing signals that were last installed about 1970. They did have some civil grading and track work. BNSF had substantially more track involved in their portion of the project. The three objectives I wanted to try to get for y'all today to understand this project is how do you understand an opportunity to partner with a Class 1 railroad to assist them and their stakeholders in achieving their objectives, not necessarily you or your companies. Also want to identify ways to add value to the complex projects by providing logical, timely, and economical solutions with your clients, not just for your clients. And then address some of the lessons learned from the project and translate them to value-added services. Now, Tyler gave you a quick little background, but for those who've never been or even seen Fort Worth on a map, for Tower 55, state of Texas, and most other states, when a tower was established at an interlocking, it was assigned a number, a random number. This one just happened to be Tower 55 in the state of Texas. It was originally established by Texas and Pacific coming from Dallas into Fort Worth in 1875, and then when the other railroads came through in the late 1880s, early 1890s, we had a junction there. So the history: in 1873, B.B. Paddock was a merchant in Fort Worth who had a vision for bringing more folks into Fort Worth, and he had drawn up this map, which is shown here, and it came to be known as the Tarantula. So in 1904, that's when the railroads went to the state and they developed Tower 55. Let's see. So, like was mentioned before, after a century of functionability here, Union Pacific and Burlington Northern Santa Fe currently are the two Class 1 railroads who meet at Tower 55. Amtrak has 4 trains that are also served by the tower. The different cargoes that are brought through are intermodal goods, agricultural products, coal by the tons. Half the traffic's probably coal trains, then industrial and manufactured goods. Now this is one of our plan sheets. It was an actual exhibit, but downtown Fort Worth. Let's see how. Downtown Fort Worth, right here, you can see the Trinity River. This was one of the constraints to our project. We went north up to the Trinity and then south and down the south side Fort Worth. The green is BNSF. The orange is Union Pacific's improvements along their track. Now, consultants, suppliers, and contractors all partnered from the pre-bid process, developing what materials were going to be required or would be best suited to the project. We met with the BNSF and Union Pacific, as well as Amtrak, and other outside stakeholders, including property and land developers adjacent to a couple of the crossings that were closed, and grade separations which were improved. We also met with Fort Worth Independent School District as well. Now, from the get-go, HDR assisted the railroads in multiple facets. One thing we did, we assisted both railroads in the modeling that on the BNSF side of life, their transit times had increased more than 30% since 2002. And some of their trains were staged all the way from the Oklahoma state line and southward to Temple, where it begins 2 new subdivisions. They'd be staged there for approaches into Fort Worth. That impaired their growth and sustainability at Alliance Intermodal Facility, which is located just north of Fort Worth. Union Pacific, that impacted more of their east-west traffic, which they would stage 30 miles to the west in Weatherford all the way out to Abilene, which is 150 miles west, to approximately 100 miles onto the east of Dallas. And this impaired their services to their, it's less than 10 years old, their South Dallas intermodal facility, which is still increasing on their traffic. We also assisted the railroads from the financial standpoint. When this project started, that was before President Obama was elected. Therefore, a lot of the funding that we used didn't even exist. But once he was elected and instituted the Tiger funding, it changed the whole program when the railroads went and applied for public funds. So we assisted the railroads in developing the applications, the paperwork, the reports. We worked with the BNSF and the Union Pacific, as well as the FRA, and TxDOT was the sponsoring agency in Texas. So once we obtained Tiger II funding, that was $34 million from the USDOT. The breakdown of how the funding was for the project: Union Pacific $39 million, BNSF $37 million, the $34 from USDOT. Our local council of governments was $2.5 million, TxDOT $1 million, and City of Fort Worth $1 million. Then from the engineering and management perspective, they had a preliminary 10% design that had been developed by another firm as well as with the railroads, and base agreements or handshake agreements had been made, but nothing in writing. We took those 10% design plans, evaluated them, saw some problems that would have stopped the project, like going through the oldest cemetery in Fort Worth and knocking out 13 graves. But, you know, things like that. We made some modifications, took it back to the railroads. They approved them, and we forwarded the design. We also developed permitting from the historical documents, geological, as well as wetland permits. And then we coordinated with the City of Fort Worth with what's called community facilities agreements, where if somebody outside the city is to design and or build facilities that belong to the city, then we have to agree. They will then reimburse the railroads for the work they did on their facilities. And then we, HDR, assisted BNSF by providing resident engineer and project management assistance throughout the construction phases. Like I said before, one of the stakeholders was Amtrak and Fort Worth. Currently, we have the Heartland Flyer, which serves between Oklahoma City and Fort Worth, and then we have a train coming through from Chicago through Fort Worth on the way down to San Antonio on the Texas Eagle. So we made some modifications to the track alignments that they run on, which would then improve their operations and improve economics and safety for the BNSF as well as Union Pacific, and reduce their delays through the tower. From the operations standpoint, Tyler got to meet a couple of times with us, but we had a couple of dozen meetings with the transportation departments, signal departments, operations, facilities, all sorts, and trying to look at the overall project to ensure that trains just did not stop during the design or construction and phasing of this project. So we went through construction phasing, developing individual phase design sheets, and we did that 25 times just to ensure that everybody was comfortable with what had to be done, could be executed within the time frame, and not stop any trains. A part of this did include communications between these two railroads as well as others on reroutes and schedule modifications. The biggest thing that we did that really helped was there was a hole in the donut that was the diamond right here. Oops, shoot. What did I hit? Wrong button, sorry. Right here at Tower 55, the diamonds where the tracks cross each other, those had to be replaced. They were a 2x2, 2 tracks going over 2 tracks. Those had to be cut out, and we replaced with 3 north-south diamonds tracks going over 2 east-west. Then we also had to replace a bridge that both railroads ran over. Both of those bridges were actually separate, even though they appeared to be a single bridge, and we did that in phased demolition and reconstruction as well. What we did, we moved it to the end of the project, which expedited the overall project schedule. Now, when we were looking at the structures, some of these great improvements, from my particular standpoint, working with the BNSF, this is one particular bridge. This was a 9-foot, 9-inch vertical clearance, just barely wider than a single lane of traffic, and it was skewed. Emergency vehicles nor school buses had ever been underneath the Santa Fe BNSF through its history. So we took that, we envisioned this, and then this is what was actually built. We went from this phase to putting retaining walls, additional sidewalks on each side, so we improved pedestrian safety and access to the schools and future businesses and residences. Then on the track side, this is where Tyler and I had a lot of fun modifying things multiple times, but we developed track alignments based upon the operation models that were handed to us by both railroads, and then we helped meld both of their programs together in the design phase, even down to making sure the survey was tied together on the same state plane coordinates, so we knew where the track centers were in relation to each other in real space. We also evaluated and coordinated the bridge clearances through the City of Fort Worth and both railroad structures departments. We ended up closing 2 existing at-grade crossings to improve traffic flow, rail traffic flow, and improve bicycle and pedestrian traffic for a local school. With a project of this magnitude, it wasn't just moving a bunch of tracks around. If you move tracks, you've got to move signals as well. And like I said, both railroads improved their block signal system. Their signal and communications also included PTC coordination and installations. This is one location where the BNSF was installing one of the PTC control units beside the signal block. But with the final track design, the signal guys always want to see the final product versus working with you from the get-go. And that was a little bit of a challenge, but we were able to get plans developed far enough along where we could provide it to them, they could begin working with their designer. And we ran pretty parallel right up to the beginning of construction, and then the signal guys had to wait till about halfway through construction before they could start getting their foundations and facilities set in the ground. Let's see, we also provided additional signal equipment, the berms for the bungalows to be located, the signals to be located, generator houses and such. And even at the end of the project, the railroad came back and said, well, we want to be able to have alternative power, so we were providing gas energy sources to them rather than just electric. So it was always a moving target. Then with the city coordination, we went through the City Planning and Development Board for closing the 2 crossings. We coordinated through the Fire Protection Engineering Department to ensure that we had emergency access during traffic phasing. We were also installing Traffic signals for 2 intersections. Since we were closing 2 existing at-grade crossings and improving clearances, we changed how the fire department and the police department had ingress and egress to 2 separate neighborhoods adjacent to the projects. We also worked with Transportation Public Works, the storm sewer, the water department, traffic engineering. Tree permitting is always an issue with most large municipalities. And then we have multiple plan reviews and comment resolutions through the city. Now, adding value to a complex project, sometimes that sounds overwhelming. Other times you think, well, that's nothing. We can do it. So you go and you have to do an analysis on your project and how you can best provide a logical, timely, and economic solutions with your clients, not just for them. And when I say with, that means being involved in a dialogue. You know, you work with them to a level where you excuse me, gain their trust and they understand your professionalism and your knowledge. So you work as a team to provide the best solution to their problems. Now, this is a real issue, and sometimes it's really simple. There is a way to save time and money, and always remember, time is money when you're in the construction phase. During the design, we had a really tight right-of-way along the BNSF, and this was a series of 5 conjoined buildings, distribution buildings, that would have been multiple $1 million. But what we did, we recommended a retaining wall with adequate clearance from the back wall to the railroad right-of-way. In this photo here, during the construction phase, the contractor was having a hard time staying within his own schedule. So what we did, we had a conversation with the contractor and the railroad and recommended removing the lime stabilization or the chemical treatment to the subgrade, and we recommended biaxial geogrid material to be installed, which saved money all around and then saved time, because we probably saved a month worth of cure time on the subballast if we'd installed lime. Another example, bridges are always more expensive to build and to maintain through life cycle. So this bridge really wasn't there for drainage. It had been built at a time when this section of Fort Worth was more agricultural, and there had been an irrigation trench coming through here. It no longer functioned that way, so we recommended and designed and installed a concrete box culvert. It's backfilled. They don't ever really have to look at it but once a year. And then this is where we moved the demolition and the reconstruction of 2 bridges to 2 consecutive weekends at the very end of the job, like 3 weeks before all the track was completed and we were preparing to walk away from the project. So then we have the construction management team. Once we were out there, I had a staff of 6 people on a daily basis, and we developed the materials testing schedules. Remember your concrete lab and all that, everything you learn there, it actually gets executed out during construction. We developed construction observation schedules, as well as the folks out there looking at our structures, our bridges, our culverts, our retaining walls, everything that, then when it came to the city construction, we coordinated and provided information to the city inspectors and engineers as well. Our responsibilities also included the paperwork and the change orders for the railroads, as well as coordination with the state and U.S. DOT on a monthly basis. Project safety. That's something a lot of people take for granted, but it can either save your life or get you kicked off the project if you're caught not being safe. Some of the instances, that a lot of times you take for granted is just how close or what kind of equipment you're working around, even if you're not in control of it. This is railroad's track gang, but you see the back end of that track hoe lifting up off the ground, and they're moving and pulling that track. If a chain breaks, you you don't want to be in the way of shrapnel and projectiles. Sometimes you're working close to live tracks, and there comes at 30 miles an hour passing by you, or you might be up on adjacent structure with live traffic. You've got different materials you've got to be aware of. Even with concrete, you can get chemical burns. You know, you want to make sure you're paying attention to what you're doing, or overhead movements of structural materials or other materials being delivered. Some of our construction observation activities said we had the placement of bridge girders and cast in place components of the bridges, be it the drill shafts, placing the cans, the rebar for reinforcement, and then pouring the concrete for the substructure, and then setting the superstructure like shown in that last slide. You also, during embankment construction, you're testing your moisture and density as you build up every half foot to 8 inches. Sometimes you have differing conditions, not only the weather, but we did night work out here as well, sometimes required 24-hour cycles. This is where Union Pacific was working in the summer, I think in July of 2014, the night they removed the existing diamonds, excavated the old sub-ballast out, put down geogrid, asphalt material, sub-ballast, and then had a huge crane drop the assembled 3x2 diamonds in place and set them up, and they had slow order, but they had trains running by 6 the next morning. And then, like I said, too, in working with the signal department, you have various kinds of structures, different types of signals on wayside or overhead, as well as their appurtenances. Something that, I'd been in transportation for probably 20 years and working in railroad for 5 years, I never got the chance to be around the track laying machines. I was always out there getting all the civil work done, structures, having everything ready for the track to be laid. This particular series is the BNSF's track laying machine. And what they do is when you have the sub-ballast ready and approved by the engineer, they will line out all this continuous welded rail adjacent to where the center line track is already surveyed in and staked and string line. This is actually a train. They have multiple flat cars with concrete ties ready to be set down, and this yellow portion of the train is actually a bridge, rubber tires on the front end being pulled by a Caterpillar dozer, and as it creeps along, it sets all the ties in place. Another portion of the train then grabs the rail and sets it up in the tie plates, in the seats, and then as it goes along, they assemble the clips, and you've got a skeleton track ready to go. They'll have ballast on it on that afternoon or the next morning. Now, some of the lessons learned and how we have translated them into value-added services. Before I jump off of this, like I said, I wanted to expose y'all to various things. This is some eye candy, so I'm not just going to run over this, but here is some of the day work after the new diamonds had been set in that morning before they opened it to traffic. This is some of the work we did that, because this is an older bridge structure, didn't want people having to come in there. There's no longer the bridge. This is where that former timber trestle was when we put the box culvert in. You don't have quite the same access, so they aren't going to be out here wanting to maintain and herbicide the grass. We put the rock riprap, and it also helps with maintaining the slopes in case of heavy rains and water rushing. This is also where the railroads were managing the city utility improvements. And then out along the Amtrak ramp, we did get into an area where we found some contaminated soil, so you have to be prepared on how to handle that, getting the proper calls, the proper permits and paperwork done, and expedite the removal and disposal of that material. So results now in trying to exceed our client/owner's needs and requirements. We began the construction in March 2013 and completed the construction less than a year ago in December of 2014. Substantial completion was in September of 2014. Of all the bids received, they are approximate to the engineers' estimates. Actually, on half and half, the engineers' estimates were dead center between all the submitted bids. And we executed all the, and I say we, both railroads, because it was a combined contract with the USDOT FRA. All the contracts were executed within the flow-down agreements that were signed between the different agencies and the railroads, within those guidelines, within time, and within budget. And actually, BNSF, I don't know about the UP's final bottom line. BNSF actually was 0.5% cheaper than was originally bid. It goes a long way when you can do that. This slide here is a presentation that Union Pacific and BNSF had at AREMA, but it's pretty interesting because you get to see some of those work windows with a lot of work being done within just a couple of minutes. So, let's see here. No, that's not what I want. You have to click here. Okay, get it? Okay. And it's pretty self-explanatory, but it's some of the track relocation and reconstruction on the Union Pacific side, as well as the diamond removal and construction, and then the demolition and reconstruction of the Lancaster Bridge. You can see the high rail equipment, the tampers, as well as the regulators, trying to finish that track after they got it laid in place. Here's a month later, then 2 new main lines to put a total of 4 back freight main lines in service. Union Pacific's largest yard in the area is located about 4 miles to the west of this location. This operation, since Union Pacific actually controls the tower and access through the tower, they were in charge of all the removal and construction of track on this weekend. See the moon down there? And I wish you could really see that crane, because it was the second largest crane I've ever seen. You can see it in the background over here on Saturday morning. What made it interesting, Union Pacific had brought in a crane that's sitting just out of the screen. Had been there for a week, and the day before everything was supposed to happen, they blew hydraulics right out of it. Had to find a new crane. They shipped it up to Houston, had it ready to go that morning early, and moving that afternoon. on that particular bridge. Those were bridges of different eras, but all of them were at least 80 years old iron and steel. We cast them within reinforced concrete to make it look new and reinforced, and then set new headers up there and new steel girders for both railroads. So with all the improvements that were made through this project, we added approximately 40% additional capacity, which ought to last the railroads for another 20 to 25 years. It also improves the safety for the traveling public at grade crossings, as well as the bicycle and pedestrian traffic for the kids and other neighborhood traffic, and also improves air quality by removing substantial queues on the rail, as well as some of the traffic hiccups that would occur adjacent to the rail lines as well. Some more of the eye candy. If you have questions later, we can come back to. It was just a year ago and 1 week that we actually had the ribbon cutting, so all the people who signed the letters, signed the bills, helped get the money and everything else, they all met out there and cut the big blue ribbon. Union Pacific and BNSF both each provided a brand new locomotive right there at the Diamonds. We made the cover of RT&S magazine the next month, so we got a little recognition instantly. So Ed Hamburger, who's actually the CEO of the Association of American Railroads, he had this to say, that with over $1.1 billion in public benefits, Tower 55 has addressed needed network capacity and eliminated key freight and passenger bottlenecks through the implementing a creative engineering approach, an extraordinary collaboration between the Class 1 railroads, and the creation of a public-private partnership. You will learn that little catchphrase because it'll probably be implemented for the rest of your career. 3P, or public-private partnership, using private and public monies to expedite a project. This also has brought on follow-up projects to go along with it. The USDOT FRA approached the railroads of monitoring the success of this project to ensure that the public money was invested properly and was worth its investment. So what we're doing, we had the baseline trackage alignments. We did modeling to show impacts to various grade crossings, 10 different grade crossings around Fort Worth and its suburbs, air quality, and then we are to do that each year, 1 year after the completion of construction. So we are completing the first round of follow-on monitoring and documentation now. We've got 4 years remaining. Then, as Tyler noted before, the Tower 55 project has won the Hay Award from AREMA back last month, and we were also notified that AASHTO had presented the 2015 Presidential Award. So with that, HDR, besides thanking y'all for giving us the opportunity to talk to you today and give you a presentation, we thank BNSF and Union Pacific Railroads for allowing us to be part of this substantial project and the success we've all had. So with that, if y'all have any questions, I'd be happy to try to answer them anyhow. Yes, sir.
Get a little bit away from the engineering and sort of more into the legal and business side of this. This is a fascinating case study, right? You've got two companies that are basically competitors. And you've got public money involved. So what and the companies are providing, as I understand it, a lot of the labor.
For the track and signal, yes, sir.
So was HDR, were you essentially a general contractor? Were you
we're a consultant. Started out, we'll have to go back before the elections of '08. We had been approached by BNSF for their portion of the civil design. knowing that we were going to be coordinating with Union Pacific as well. At that time, it was still two separate projects married at the hip with handshake agreements and documentation in place.
And you expected to work for BNSF?
We were working for BNSF, yes, sir. Union Pacific did, as far as I know, they did all of their track work, track design, and geometry in-house. We then came along, and at the 30% design phase, we were actually presenting our bridge plans at one of the joint monthly meetings. And because of the complexity of the East Lancaster Bridge, and Union Pacific said they would like to be in control of that themselves, realizing both railroads utilized, different portions at different times. Then Union Pacific took that bridge and gave 100% of it to HDR. HNTB was the bridge structural designer for Union Pacific previously. They still had other bridges. We didn't take off. It was just that one bridge. Through that, we saw some permitting issues that need to be addressed on the Union Pacific side versus BNSF. They requested that we assist them with that, which then came into some utility adjustments and design that need to be done, as well as some right-of-way acquisitions. So it was one of those projects we didn't go out and solicit, but it fell into our lap, and we were able to assist them because we were familiar with the site, with the conditions, and the history of the project. So from that, once we got 200% design through all the parties conglomerated, construction bids went out this time last year. We had pre-bid meetings the first week of December. Bids were due second week of January, and I think both railroads went to construction in March. UP may have started first week of April.
So did the railroads jointly employ the subcontractors, or did they each have their own subcontractors?
To make things simple for their own paperwork and tracking of the projects, as well as the legal aspect, like you said, through the federal program and obtaining the funding, it was treated and managed as a single project. As far as USDOT, FRA, everybody else, it was one project, both railroads. But when it went to construction, all the agencies agreed and allowed Union Pacific to bid their portion with their contractors and subs. BNSF bid their portion with their contractors and subs. HDR was already online to be CM for the BNSF. Another company did the CM for Union Pacific. And then there was actually a third party who coordinated with both CM companies so they could go back to TxDOT and USDOT FRA with our monthly reports and ensure it wasn't the fox watching the hen house.
And ultimate responsibility, though, is still with the
railroads. Yes, sir.
To each other. So if that crane had dropped those diamonds and shut down the other guy's railroad,
there'd been a few legal meetings, yeah, I'm sure.
That's
Don't even go there, I don't think.
one of those projects that is great when everything works.
Because as much tonnage as that picked up, if you're looking at the track, it looked like it was moving slow as they were moving it. But when you looked up and saw that boom, it was doing like this. It was something that night.
Well, I think this is a lot interesting as an engineering case study, but I think also be something that would be of interest sort of on the legal and business side as far as how you coordinate a project with that many responsible agencies and responsible public.
So they'd use a lot of words we wouldn't understand, though.
This is true.
Okay.
And get paid more.
Yes. Anybody else have any questions or comments? Yes, sir.
You mentioned one place in there where you had lime treatment and you replaced it with the geotextile.
Yes, sir.
I know that along I-35 they have a lot of soils that are very unstable with moisture change, volume swell and everything, which lime generally helps. Did you run into any problems with your soils swelling, shrinking, and anything like that?
Fortunately, we did not. Fortunately, I had worked for TxDOT for 15 years before I got into consulting, and me being from Fort Worth, I was also familiar with the different problems around the county, around the city. Downtown really did not have bad soil conditions, and through Fort Worth we get the gray shale and limestone usually within 25 feet. The only place we had some issues, we excavated it out and put retaining wall up, and the backfill was granulated fill. So we were fortunate, but that's one of the reasons we went that direction. Yes, sir?
The benefit of, well, first of all, it's a fantastic presentation. It's great to see a lot of things that I drew in a computer turn into real stuff on the screen and pictures.
Mm-hmm.
But for the benefit of some of the students here doing research in the area, can you talk a little bit about the decision to use concrete ties on a lot of the track construction?
I hope you don't mean from an engineering standpoint. I'm not going into physics and dynamics today. A lot of times, I guess primarily where it started out with both Union Pacific and BNSF, the predecessor railroads, they started using the concrete ties on their systems for the coal haul, where you have megatons, megatimes, you know, especially when you consider coal cars tend to be the same weight, same size, similar manufacturers. You get a cyclic movement. So now we're on continuous welded rail. The concrete ties help support that kind of traffic for a longer duration. You don't replace them. In a lot of cases, even though timber ties do hold up better than they used to, the concrete ties will hold up an additional 10 years. And I guess now it's not so much the coal haul, but they still look at how many megatons of traffic are operated over that subdivision per year. Because the project I have right now, it's tying two existing sidings together, which the existing main line is all timber ties, but the new track will be concrete ties because they're expecting 100 megaton of traffic coming up for the next couple of years. So they're going to go ahead and make the investment now. Is that anywhere near what you were hoping for? Okay. Okay.
There's also some aspects of the track lane machine needed construction. I remember one time we were talking about that.
And every railroad's track lane machine is different. Some things work better for different operations. Some started out using contractors versus their own gangs. Excuse me. I believe BNSF has 2 TLMs for the entire system. So they sit down like your pre-draft of your fantasy teams a year in advance. They're going to figure out what regions the TLM is going to, and this is before you've even completed the project, and sometimes before you even award the project. So it makes it challenging. But they've got a schedule, and this is union labor they're utilizing. It costs them a lot of money to get this equipment moved around and put down millions of dollars worth of track every year. So when you're considering the track lane machine, you have to have a wide enough area for the equipment to get in and onto existing track, adjacent to. So most of the time you're either going to use an existing siding or install a temporary turnout. So as that machinery starts walking down the roadbed, it's just laying that brand new track, skeleton track down. You got to make sure it has a place to move out. You got to make sure that contractor has his roadbed in place properly. If you got soft spots, you're already introducing problems for the railroad on their maintenance for future.
Actually got a question from our online microphone. So it looks like Mike Garcia at Illinois DOT question here. Were the railroads required to comply with the disadvantaged business enterprise goal or requirement for the project?
No is probably the correct answer, which surprised everybody since we obtained public funds. We were expecting, 20 to 30%, which is in line with what TxDOT is required to have in North Texas. But I think a lot of that was because each railroad has their individual programs where they do employ disadvantaged businesses, women-owned businesses, military, and everything else. And they both have been awarded for their attributes and accomplishments in that area. So we did not have a set percentage required, but we did have, I think they were awarded extra points on the bids for their disadvantaged business, as we were when we were awarded the design project from BNSF. Yes, sir.
Do you have any specific interesting problems with pedestrians and rail trails, and did you have to go over or under?
When we were trying to close one particular grade crossing, there were two crossings we closed. The place I expected the most foot traffic and trouble, just because people are creatures of habit, a lot of the employees, downtown employees, would park on the street and walk across the tracks. And it was already a double track section. For some reason, everybody had good reasoning and sense and decided to park elsewhere during construction. We didn't have problems there. But the crossing adjacent to the elementary school, again, people are creatures of habit. It was tough to get them to walk a different. It was really the walking path, when we measured it, I believe it was just under 800 feet additional travel distance than what they were using at the closing of the crossing we were closing. And during construction, some people, I don't know if that's stunts or just don't think, you know, they would keep on walking out there when we had construction equipment. They'd walk out when trains were still passing by. But that is also the reason we designed and installed 8-foot tall right-of-way fence and not just chain link. I mean, we used a fence I had never used before, but when Union Pacific was making some improvements out by their Lancaster or Davidson Yard on the west side of town, it followed up another contractor who had done some improvements along the BNSF on the south side. And so the city had come to me and said, we would like for you to look at this material. When I did, it turned out it was actually cheaper to install that 8-foot, nice-looking powdered paint colored fence. Was about 3/4 the cost of a standard 4-foot chain link fence, which anybody could tear down or climb. This son of a gun, they've got to work at if they're going to tear it down, and they're not going to climb it. So, you know, I put a few extra 100 feet from the crossings, and it blends in with the landscape, and it protects everybody. And this is adjacent to some new high-priced condominiums as well. And so we received the blessing from their developer and contractors. So it worked out for us. Going? Going?
Please join me in thanking Mark for an excellent summary.
Appreciate it. Shoot.